Well, we demonstrated in a previous video. I haven't edited it for YouTube yet, but we took some instantaneous meter readings and found that what we needed to know about what our phase angle diagram is going to look like in 3 dimensions, and it looks like about like that. But to explain that, what we did is we analyzed the wattage loss on the primaries, and we looked at the wattage on the secondaries, and we found that they're almost equal. That's the I squared R loss. Now we had we only had 2.77 watts I squared R loss on our primaries, but that was also duplicated on our secondaries. So that brings that up to a little bit over 5, and then we had 17 watts total apparent power input. We're going to look at the secondaries real quick and try to show a medium range Tesla coil today. So we get in there and turn it on. Oh, come now. I'm going to make some more phase angle drawings. We analyzed the 12 one. But first we're going to look over here. Right now we have those 2 secondaries. We have an amperage meter on one of them secondaries. Showing 112 milliamps. These are 7,000 ohm reactance. So that would imply that for every milliamp we have 7 volts. So, yeah, that's 700 volts right there on that coil alone. And the other coil, I think, is unengaged. Okay, we got 113 milliamps going through a 140 ohm secondary coil right now. That's the front coil. We haven't hooked up the next one. We'll hook up the next one. Now we found that that one went up to 139, 140. A lot of fluctuation. And now we'll measure the other one. And the second coil has 133 milliamps. Okay, we can say each coil then, each of them secondaries has about 135 milliamps going through them. They're 140 ohms. On our primaries, we have phase 1 at 7.78 volts. Allowing 0.3 amps. Phase 2, 7.7 volts, allowing 7.7 amps, and we have right, 7.7 volts, enabling a 1.5 ohm primary to display 0.59 amps, 0.8 amps, and 0.28 amps. We want to note these and find out what I squared R will be at 1.5 ohms. And then again we go back down here. We want to know what I squared R for those two coils will be at 140 ohms resistance, conveying 133 some milliamps. I'm going to note those two values afterwards of this video. That is our starting condition before we engage the Tesla coil. Right now we have a common between those coils. Let's eliminate the common and see what happens with that coil. Nothing happens. Okay, we can see then that we got this 130 milliamp circulation from them two secondaries with the common point. Now we're going to drive a Krypton bulb with that. And as usual we say, why ain't it driving it? Now we're driving a Krypton bulb with that. Secondary voltage. And we've noted now our amperage appears in the 70 to 80 milliamp range. That is our load down. That will be the subtraction of secondary current upon loading. Now that we've shown that, we'll go back to the Tesla coil and make our arrangements for the primary arc gap. Or rather, we'll call this video quits and then set that up and make